In this video, we're going to talk about acid-base and gas evolution reactions. I'm actually going to do number 87 from chapter 4, which is a gas evolution reaction example. So 84 asks to complete and balance each gas evolution equation. You are given the reactants and you need to determine those products. So the first thing you should do is look at table 4.3. These are all types of compounds that undergo gas evolution reactions. So when we're given our A, all we need to do is identify which of these compounds, which reactant type we are actually going to use. So in A, we have HBr and nickel 2 sulfide. So is the reactant type A sulfide, carbonate and bicarbonate, sulfites and bisulfites, or does it contain ammonia? Well, it has this sulfur, which means that we are dealing with a sulfide reactant. So we know that H2S is going to be a product. Okay, so if H2S is going to be a product, that takes care of our sulfur and hydrogen, so we are going to be left with NiBr2. The reason we are left with Br2 is because here the oxidation number for nickel is a +2, as sulfur is a -2. Here the oxidation number for hydrogen is +1 and bromine is -1. So in H2S, the oxidation number for hydrogen still stays at a +1 and the oxidation number for sulfur still stays at a -2. So during this reaction, we are not changing the oxidation state, which means that our nickel 2 bromide, the nickel needs to have a +2 charge and the bromine needs to be -1 as well. Okay, so this is our completed reaction. The only thing left to do is add our states and balance it. So H2S, that is a gas, and the nickel 2 bromide is aqueous. Bromine creates aqueous compounds. There are a couple exceptions, but nickel is not one of those. And now we need to balance it. So on our product side, we have 2 hydrogens and 2 bromines, which means we need a 2 on our reactant side. And that's it. Our equation is balanced, and we have shown the gas evolution products. For B, again, we need to look at table 4.3 and identify which reactant type we have. So we have ammonium, we have iodine, we have sodium, and we have hydroxide. The only reactant type that's relevant then is the ammonia reactant type, so we would expect ammonia to be a product. So NH3 is going to be our gas product. So we have we have 1 hydrogen left over, and we have the remaining elements left over. So what to do now? Well, if we have 1 hydrogen and we have an OH group, those are going to combine to form water. Okay, whenever there's just 1 hydrogen and an OH, it's always going to be H2O. It's going to form water. And then we're going to have NaI as an aqueous product. And that takes care of all of our atoms that we have. The equation is completely balanced. Notice we have 1 nitrogen on both sides, 5 hydrogens on both sides, 1 sodium, and 1 iodine. So this is the entire equation.